This video is designed to illustrate the use of growth curve modeling with repeated measures data being nested within level 2 and level 3 units. The example is actually coming from chapter 6 of this book right here. The data set was downloaded from this website, and it essentially entails looking at graduation proportions across an 11-year span with those proportions being associated with particular four-year institutions. So in our data set we have this variable right here. This is essentially the level 2 a level 2 identifier for four-year institution, and this is a unique code associated with each of the institutions in the data set. This variable right here is the state level identifier, and so this is actually the level 3 units that we're going to be working with are states that the institutions are nested within. Now we also have another variable which is RID, and it's essentially an identifier associated with each institution within each state. And so when it comes to identifying the institutions and states, we're going to be using these variables when carrying out our analysis. We have a variable in the data set called time. It's coded 0 through 10, and 0 is associated with the initial status in terms of graduation proportion, and 10 is associated with the ending status in terms of graduation proportion. Now the authors in the example actually recoded time into a new variable called time1 using their alternative coding approach, and essentially times 0 is still given a code of 0, but the time code of 10 on the original time variable is recoded into 1. So you can see that now the time variable is incrementing in 0.1 units. So what the authors actually did in their demonstration is they initially began by looking at the relationship between time and graduation proportion, and testing essentially a quadratic trend to determine if that might be an adequate representation of the change over time in graduation proportions. They actually found that the quad time variable is not statistically significant. So the bulk of their example actually then treats graduation proportion as a linear function of time, although they ultimately allowed the slopes for the time predictor to vary between institutions. So that's what we're going to stick with in this example. So to run our analysis, we're going to click on Analyze, Mixed Models, go to Linear. We're going to move the RID variable and state ID variables over to the subjects box. We're going to move our time variable over to the repeated box. And you'll notice that what happens is that when we move this variable over, this box highlights, and so now we have options of various types of covariance structures at level 1. A diagonal matrix assumes that the residual errors at level 1 are unequal across times, but that the correlation or covariance between the errors are essentially 0. So in their demonstration, the authors actually used an AR1 or autoregressive 1 covariance structure. So essentially when they chose this particular structure, they are assuming that the error variances are equal or homogeneous across measurement occasions, but that there's a significant autoregressive component or a correlation between adjacent measurement occasions. So we're going to stick with that. Click on Continue. We're going to move our grad proportion variable over to the dependent box. We're going to move the time1 variable over to the covariance box. Under Fixed, we are going to move the time1 variable over as well. And then under random, we now have to specify random effects occurring at the state level and at the institution level. So the first step that we're going to take, we're going to actually move state ID over to the combinations box, click on time 1, move it over, and click on include intercept. So at this point, what we're specifying is that we want to estimate the variance of the intercepts between states and also the slopes between states. And we're going to actually stick with a, just go ahead and highlight the diagonal covariance type to capture that idea. So essentially what we're doing is we're treating the variances for each of these parameters at level 2 to be different from each other. So, so that's what we're doing with the diagonal matrix. Next, we'll click on, well, next, and then we'll move our ID over as well as the state ID variable over. And so when we click on time, move it over, and include intercept, and then select diagonal matrix, again, we're essentially allowing the intercepts and slopes to randomly vary, but in this case we're talking about we're addressing the random variation between the four-year institutions. So now when we click on continue, under estimation we'll stick with the restricted maximum likelihood and just remain true to Heck et al.'s presentation, and click on continue. Under statistics we'll ask for parameter estimates, tests of covariance parameters, covariance and random effects, click on continue, and then on OK. Okay, so in this case you'll notice that we have 8 parameters that are being estimated. We are estimating the grand mean of the intercepts, and so basically the grand mean of the intercepts is essentially going to represent the average across states in terms of the proportion of students graduating at the first measurement occasion, or basically the initial status. The time 1 is estimating the grand mean of the slopes for this variable across the states as well. Then when it comes to the random effects, we have random effect at the state level, or level 3, and then the random effect at the institution level, this is level 2. And we have diagonal covariance structures specified at both of those levels. So essentially we're estimating the intercept and the slope variance between states, and the intercept and slope variance between institutions that are nested within the states. And so that's why we have essentially 2 parameters that are being estimated that are associated with these covariance structures. And then the autoregressive, first order autoregressive structure, we're estimating the variance of the residuals as well as the autoregressive component. So there's 2 parameters being estimated there. When we scroll down, you'll notice that we have the intercept, which is 0.411, and given the coding, which on our time variable, which ranged between 0 and 1, we can say that this is the initial graduation rate across the states, or between the states. So in other words, the average graduation rate across the states is around 41%. Then we also see that we have time emerging as a significant predictor, and so in this case we see that there's a significant relationship between time and graduation proportion, signaling that the graduation rates appear to be increasing over time. When we look at our estimates of covariance parameters, you can see that we have our estimates of the autoregressive components. This is essentially an estimate of the variance in the residuals, and then there's our autoregressive component, and so both of those are statistically significant. When it comes to looking at the level 3 intercepts and slopes, these are the variances for both of those, and you can see that there are significant between state variation in terms of the intercepts, which is the time one or initial status in terms of graduation proportion. So there may be state level factors that predict variation in the intercepts between states, but it doesn't look like there's significant variation between states when it comes to the time slope. With respect to the between institution variances, we see that there's significant between institution variance in the intercepts. So there may be institution specific factors that predict differences in the initial status when it comes to graduation proportion, and we also see significant variances in terms of the time one slope. So there it is here. So that basically kind of provides an initial look at the variances at level 2 and level 3. So the authors actually continued on by adding in time varying covariates, and so the variables that they incorporated was tuition. In other words, kind of reflecting, higher versus lower tuition levels, and percentage of financial aid. And so, but these are time varying in that they're not constant across the years, but rather each from year to year there are differences on these two variables. And so, what they ended up doing was they reran the analysis and incorporated percentage of financial aid and tuition as predictor variables. And so then they basically clicked on fixed and moved these variables over. And so in this particular demonstration right here, we'll just go ahead and click on OK, leaving everything else exactly as it was specified previously. So right now we're running it. Sometimes it takes a couple of seconds to get things to run, finish running. So you can see right now in terms of fixed effects, we've got percentage of financial aid that's being added as that slope is being added as a fixed effect, and then also tuition right here. So looking as we scroll down and we look at our fixed effects, you can see that there's still a significant positive predictive relationship between time and graduation proportion. So we do still have evidence of a linear relationship between time and graduation proportion across the institutions and states, basically. And then when we look at percentage of financial aid, this is the regression slope right here, and you can see it's not significant at the conventional 0.05 levels, but basically the positive coefficient here suggests that institutions that had a higher percentage of financial aid also tended to exhibit a greater proportion of graduation rates over the years. When it comes to the tuition variable, we also see a positive relationship, and that is actually statistically significant, indicating that that in years that are associated with a higher tuition rates, there was also a significant proportion, or there are higher proportions of graduation rates. So at any rate, kind of scrolling down, we see in terms of the estimates of covariance parameters, we still see the significant autoregressive components and the variance of the residuals. And then we also see in terms of the variance of the intercepts at the state level, that's still statistically significant. When we look at the intercepts and slopes varying between the institutions, both of those are statistically significant in the model. So what this translates into is that we may want to incorporate state level predictors of the variation in intercepts in the graduation proportion across states, and then also incorporate institution level predictors of the variation in intercepts and the slopes across the institutions.